Okay, so this is my second video. I'm going to show you guys how to set up the uh, practice lab as I've done in GNS3 on a computer and link that to a switch stack that is outside of the computer. Um, Here you can see my setup already, and we'll go through the process of getting that done. First thing we need to do is make sure that the NIC is set up correctly. And I've got a second NIC in my desktop here, and I'm actually using the second NIC because I couldn't find a good way to configure the first one. So you go to Network Sharing Center, Network Connections. This is mine. It's the Intel Ethernet connection. And then you go to Configure, and it'll tell you everything about it. And what you're really looking for is details, class GUID, and there's the globally unique identifier. Now you may need to do something a little different depending on what your NIC is. This is just what I've found in my research for the i217LM from Intel. Uh, but anyway, so we take that GUID and we go into regedit to edit the registry. And basically it is in HKey local machine system current control set control class, and that's where we find that globally unique identifier. And then we want to find which one of these has the driver description right here. So it was 0. And then we're going to add a D word. You can see it's already here, but we're going to add a D word. So new D word, 32-bit, and put in monitor mode, just like I have there. We'll delete that one. Put in monitor mode, and you want to set the value to 1. It's going to be in hex, but you want to set it to 1. Just leave it as hex, but over in the right column you'll see an option for 1. After you do this, then you're going to want to restart your computer. So we've restarted the computer, and of course I don't have to do that, so we can get all this out of the way. And you're not really going to tell if it works or not until you either try to connect two devices over a trunk doing VLAN tagging, or unless you decide to connect it to a switch, have the switch send information, and use Wireshark to sniff it. But so here we go. We'll start a new. Where's the new one? New blank project. I'll save that lab. All right, so we'll just do untitled. Yes, overwrite. So the first thing we want to do, and I want to mention, is that you need a iOS. You need the operating system, and the only way to get one of those is to have an actual licensed device that you can get a copy of the firmware off of from Cisco. And I'm sure there's other ways that other people have gone, about getting the iOS, but so what I'm using is the, let's see, 7200 image. That's the only one compatible right now with GNS3, or as late as I checked. So we're going to go to Edit, Preferences. Down here we're going to go to Dynamips, iOS Routers. See, I already have a 7200 in here, but we'll do it again. So it's New. We're going to pick the iOS image right there. 7200 Advent Enterprise. And what we're looking for is a 15.1, 15.2, 15.3, whatever you can get. So we'll open that one. Next, I'll just name it 7201. It is a 17200. There's no chassis for us to choose from. I left the default RAM size. It should be able to work fine off of that. Here what I've done is, see, it gives you a fast Ethernet card, but what I like to do is change that to a gig. That way you're used to putting in gig in your commands. Next, idle PC, I just like to let it do the idle PC finder. So we clicked on it, and now it's searching for an idle PC value. What this does is it throttles back the processor requirements for non-active devices, and it really keeps GNS3 and the images from overrunning your uh, overrunning your processor. Take that just a moment. Alright, so it found the idle PC value. We'll click Finish, and you see here it is right here. And usually it'll say, would you like to decompress your image? But since I've already done one with that image, I have it decompressed. But yes, you want to decompress your image. That way whenever you're booting them, they don't have to decompress themselves. So we click Apply and OK. So that got us our router. So we'll go ahead and we'll place 10 routers. Seven, 8, 9, and 10. We'll close that. I'm not sure exactly why those are showing E. They should be showing the router names. Alright, so while we try to figure out what's wrong with that, I wonder if we load that router that I just created, what it'll do. It says E as well. Configure. Change hostname. I believe there's something going on here. Let me just pause the video for a second. Okay, so I'm not exactly sure what happened, but I had to close GNS3 and open it back up again. So router 1, router 2, router 3, router 4, router 5, router 6, router 7, router 8, router 9, and router 10. Alright, and we can arrange those any way we want to. We can put them in nice order, actually. 1, 2, 3, 4, 5. Then down here, we can just do 2 rows. 7, R8, R9, R10. Alright, so we've got those in place, and just let me double check that these have the slot I want in them. Yes, they do, GEEs. So next, what we're going to do is place our breakout switch. Now GNS3 comes with a very simple internal switch. Actually, you can get to it under switches or under all devices. So it comes with a very good Ethernet switch. It's very simple. So what we're going to do is we're going to right-click. Well, we're going to right-click here, change host name. I'm going to call it our breakout switch. That's the switch that's going to allow us to get out of our NIC to our switch stack. So if we right-click and configure it, go down here, breakout, see it's only got 8 ports. Well, what we can do is right here under settings, port 9, VLAN 1, access. Click add, and it adds it. Click add again, it adds port 10. We need one more. We have 10 routers, and then we want to connect off to the switch stack. And we can leave them as access for now, or we can go ahead and make them trunks. So we can do .1q, well, double click here, then .1Q, then add. So you have to basically do the same thing. I guess it would have been simpler if I would have made them .1Q the first time. And so all we're doing is we're making sure that they do .1Q tagging so that they will carry multiple VLANs across all of the connections. That's very important for INE's workbook because that's the way they have everything set up. They pipe everything through this breakout switch to the switch stack, and then that's how you get around having to have connections from every router to every switch as you go through their labs. They'll help you get everything set up correctly. Alright, so everything's .1Q. We'll hit apply, we'll hit OK. Alright, so last part is, well, not the last part, but the next part is the switch stack. What we do is we pull out a cloud here. Okay, I can close this finally. And it's named Cloud 1, so we can change the host name, call it switch stack. Alright, then we can right click here, we can change the symbol. You can choose anything you want, route switch processor, just about anything. So what did I choose for the other ones? I think I picked route switch processor, just because it looked kind of nifty. Yeah, so we'll go with that for now. Awesome. Alright, so let's configure that. I'm going to go down here to switch stack, and for Windows, you're going to do a NIO Ethernet, generic Ethernet. You're going to have administrative access. So we're going to use Ethernet, because that's the network connection that we've actually got connected. We're going to click Add, click Apply, and click OK. Now, time to cable everything up. And GNS3 has a handy-dandy little auto cable. So we're going to click on here and click on this NIO interface, click on the breakout, and put that at port 11. So we're going to do the same thing with all of these. We're going to connect the gigs to the numbered interfaces. And I just keep them in order that way. If something's wrong, it makes for easier troubleshooting. Alright, so they're all connected. Next, we have to start them. And it's a really good idea so that you don't overload your computer, your memory, your processor, anything that may be a bottleneck for you. Oh, forgot to turn that off. This play button right here will start all of these. What could be a better option for you would be to right click, start one, and let it spin up. Because, let's see, task manager. Let's see. Yeah, so it's taking up some CPU. Let's see if we can find the actual. Here we go, the Dynamips processes. That one's for R1 that I just started. So you see it spikes on memory and CPU until it gets running. Because right now it's going through its boot process, which we can see here through the console. Oh, well, that was pretty quick. So I'm going to start all of them and come back to you in a minute. Okay, so even though we set an idle PC on the device type before we started, you can see here that these Dynamips instances are taking up almost 100%, well, 100% of my CPU. This one here is router 1 that I just computed the idle PC value for. So I can go here on 2 compute idle PC. Let's see if one of these change. And they say potentially better ones marked with a star. Let's try R3. Here we go. That one's marked with a star. So we hit apply and hit OK. And boom, we see CPU drop. So they should all have good idle PC values now, hopefully. All right, so we've got it all, set up. So we're done, right? No. So this putty program right here is for my switches. And if you see here, I have the console connections already labeled. Sometimes though, whenever the computer boots, the COM ports don't come back the exact same way, so I just labeled them 1, 2, 3, 4. They're not necessarily switch 1, 2, 3, 4, but they could be. So let's hit enter, and that is switch 1. Alright, so on switch 1, I'm going to do a show IP interface brief, include VLAN. See what VLAN interfaces I've put on here. So if you see, I've got those on here. Also, show interface trunk, and I've already set port 48 as a trunk. And we can look at that command. All I said was switch port mode trunk, right there. Took the guesswork out of it. So I'll do the IP command again to see those. Alright, so to test connectivity, we need to come in here. We're going to open up R1. First I'm going to show you there's nothing configured. So we'll go into configuration mode. Go to that gigabit interface that I've connected to and do a no shut. And that's all we're going to do on that 0, 0 interface. And we see that it's up. So now I do a sub interface 101. Can we guess what VLAN we're going to put that into? VLAN 101. So it's going to be 10.10.11. So first we want to do encapsulation.1q 101. That puts it in, that tells it it's doing .1q tagging and that it is tagging for VLAN 101. Then we do IP address 10.10.1.1.255.255.255.0. Enter. No shut. Exit. Now we can do the same with 102. Alright, so we're out of it. One thing we can do from the switch, show CDP neighbors. So we see the other switches in the stack, which are redundantly linked, and you can see that in the INE workbook they've got the layout. And then we see R1. We see it on, let's see, gig 0 and gig 0.101. Let's see if we see it again. 0 and 0.101. Alright, so let's try to ping. 10.10.11. Boom, get right to it. Let's try to ping 10.10.12. I'm sorry, 2.2. No, I was right. There we go. 10.10.21. Boom, there it is. Ping 10.10.22. There it is. So now, show CDP neighbors. We're still learning it over 0 and 0.101. I believe we're looking at some spanning tree here. No, I'm not sure at the moment. But that's pretty much how we do it. Now we can go through the INE CCIE routing and switching workbook, or if you have another workbook that you want to use, you can just configure everything similar to what they're using. Pretty awesome. All right, well, thank you.